Now, I have this model which I call the River Apes Coastal People model. I just want to spend a bit of time describing it because people often seem to get it mixed up. They kind of get confused whether I'm talking about bipedalism or some of the other things. Well, let me just try and describe it. So we've got River Apes, Coastal People, two phases. River apes are pre-Homo, so the Australopithecines and similar hominids before the genus Homo, about 2.6 million years, which were bipedal, we're pretty clear on that. And the model I have is that they lived in gallery forests, riverside forests in East Africa, as the climate changed and tropical rainforest gave way to savanna, and the trees dispersed. They didn't disperse in a random way. What would have happened is that they would have shrank closer and closer to rivers. If you look at Google Earth and pan across East Africa, you'll see these little green strips of forest meandering over the savanna, and that's basically where I think bipedalism occurred. Now, this is not controversial. Most of the literature in the recent years have placed human ancestors, hominids, in gallery forest habitats, and Jonathan Kingdon even wrote a book on bipedal origins all about this model. But what he did is he placed us on the outside edge of this gallery forest, where the forest became thinner next to the savanna, and postulated this strange squat feeding kind of hypothesis. It seems clear to me that the bipedalism would have actually happened on the other side of the forest, close to the water's edge, because that's where in shallow water basically apes have got no choice but to be bipedal. The second part of the model then, so the early part then is about defining and explaining bipedalism. What happened after that for the genus Homo is that it's coastal. So rivers lead to the sea, and our ancestors, I think, would have eventually followed those rivers and ended up on the coasts, where the food supply is much more reliable, it's not seasonal, it's rich, it's easy to procure, and it makes sense for all sorts of reasons that I've already described. Now, when I got back into academia, I decided out of all of these things, the thing that I was going to study was bipedalism, bipedal origins. And the reason I chose this is because I think it's the most obvious one. I mean, try this thought experiment. Try and conceive of a scenario where you are compelling a group of apes to move bipedally for as long as the conditions prevail, using only things from the natural world. In other words, you're not allowed to saw off their arms or use electric shocks or anything like that. Now, if you sort of look at this picture here, we can see this is a bonobo, quadrupedal on the left and bipedal on the right. It's the same bonobo, just a few frames later in a series. And I think if you're thinking the same way as I'm thinking, it's not difficult, is it? To induce bipedalism, you just put them in a tank of waist-deep water, and they would move bipedally. All of the great ape species are quadrupedal on dry land, and they all switch to bipedalism in shallow water. Depends on the depth, of course, but generally speaking, I don't think there's any other model of bipedalism that can say that, and there's certainly no other model of bipedalism that would actually kill you if you started to move quadrupedally. Now, I want to sort of skip a whole load of stuff that I've done on bipedalism, a huge lit review, and just jump straight to the point, which is a set of experiments that I did to test the hypothesis that wading in shallow water would actually make sense in terms of an early biped starting to move bipedally, and in terms of energy efficiency. There's no doubt in my mind that our anatomy is clearly adapted to efficient terrestrial bipedalism. I've not got a problem with that at all. I agree with Rodman and McHenry that the bipedalism in humans is all about energy efficiency. But the problem with the hypothesis is, how did it begin in the first place? How did bipedalism get practiced by hominids before the anatomical adaptations kicked in? And how did that process start to happen? And I think shallow water is the perfect solution to that dilemma. So basically we did a series of experiments to test the energy efficiency of bipedal wading in different depths of water, with different knee flexions and at different speeds. And to jump straight to the punchline with this slide here, we found that at certain depths, with certain knee flexions, the difference in energy costs between moving with a bent hip, bent knee gait, like an ape-like gait, and a fully upright gait is completely negated. There are obviously the shallower the water, the less the difference is, but it's this continuum between deep water and shallow water that is the perfect scenario for this sort of gradual evolution to have taken place, I think. One of the findings I think was quite illuminating is that as knee flexion is increased, you try walking around on dry land with a bent hip, bent knee, and then gradually more bent knee and bent hip. It gets progressively harder, and anyone that's done this in a swimming pool will know that it actually, if anything, gets easier, because as your body is sunk more into the water, there's more buoyancy and it becomes easier. So I think that this little experiment that we did was very simple, but it showed that basically shallow water is an ideal environment for early hominid bipedalism to have started. Now, having done all these studies, and it took a couple of years to do them really, and to do all the practices and get all the data and do the stats and publish it and get it written up and so on. It was then time to publish this work, and to me this is really what it was all about. I didn't do a PhD to get my 3 little letters at the end of my name or call myself Dr. Kalukas or anything pretentious like that. I'm really all about trying to get this idea into the mainstream of anthropology, because I think it's a very good idea. So what you're supposed to do in science is, you do the research, you do the study, and then you publish in a peer-reviewed journal, and that's what I tried to do. Now, my supervisor, Nick Milne, warned me that this is going to be difficult. People don't like this idea. You should, take out any reference to the aquatic ape, and you should go for a really low-key journal first of all and just get the idea in. Well, it was good advice, I think, but I was a bit naive and impatient, so instead we went for Nature, and of course that was rejected within about 10 seconds, so no surprise there. What was surprising, I think, though, and very disappointing, was the next journal that I went for was Journal of Human Evolution. Now, JHE had just published a couple of years before a paper by Carey and Crompton, which was more or less identical to our study. They did the same thing as us, looking at the costs of bent hip, bent knee gait versus fully upright on a treadmill, and they used the evidence to argue that Australopithecines moved with a fully extended hip, not with a bent hip, and that supported their sort of larger model, which is basically this handheld, hand-assisted sort of bipedalism in trees like orangutans do. Now, so I thought, well, this has got to be a really good chance, because the Journal of Human Evolution had just published this paper. Our paper was kind of similar, which is actually going a bit further, varying the knee flexion and putting it in water. So how could they possibly refuse this paper? Well, of course, they rejected it. They rejected it, and they said it's not related to human evolution. It didn't even go to peer review. Now, I was staggered, I wasn't expecting that. So I wrote to the editor, Susan Anton, and said, well, hold on, you just published a paper 2 years ago, which was pretty much the same study as ours. Ours is adding extra stuff on top of that. It's confirming their findings. How can you not publish this? And she said, well, we didn't realise it was a reply. Apparently the editors of JHE don't really know what papers they published in their own papers, it seems. But anyway, we were told to resubmit as a letter, a reply, a formal reply, and then they would reconsider it. So we did that. Unfortunately, the format of the reply is just 3,000 words, so we had to curtail a lot of the arguments and shorten them in order to get it within this 3,000 words. And then, of course, it was rejected anyway. At this time it did go to peer review, but the comments from the reviewers really, sickening, disappointing, terrible, really demoralising. I mean, for instance, one of the comments was that we didn't go into the 25 years work of investigating energy in reduced waste environments like Cram and Ponsner. Now, I mean, we'd just been told to shorten the paper to fit it into as a letter, and we couldn't expand that argument. It wasn't going to happen. And things about the taphonomic bias, that Lucy was a floater. Apparently Lucy had lived on the savannah and then died in the water and floated down to the swamp where she was eventually buried and became fossilized. I mean, how do they know that? Why is that less speculative than just assuming that they might have actually lived in the swamp sometimes? Anyway, so I was very disappointed.